So, yeah.
Okay, so I'm a postdoc with the University of Florida. I work on CMS, and I've been on it since 2006. And this is has nothing to do with my work at all. Well, very, very slightly, because our work involves using neural networks to analyze data sometimes. So in the very late stage of analysis, we often plug in our neural networks and we try to squeeze some signal out of background. So this is very little to do with my work. This is something that I've been thinking of since I was a kid. Since as early as I can remember, and my first memories of this kind of thoughts crystallizing in my head is way back in high school, when I was just wondering what is it that is looking out in the world, like what is this I am that looks out in the world. And I think that's a very pressing thing that everybody asks the same question. So I was wondering what could it be, and I was thinking, well, how can I simulate the brain? And I remember way back when I was a kid, I was thinking maybe I could think of it like a Rubik's Cube, where every little interface between the little cubes is a synapse, and like the face of a the one face of the cube is the inputs and the other face is the outputs, and you can think of how the connections go through. And this idea has been progressing in my head for a while, and I think I've come to some sort of answers, potential answers, to a few central questions about consciousness. So I'll come right, I think she's joined. Yeah. Hey, okay, alright, I already started. Oh, hey. Oh, there's two people. Okay. Back to...
Did you start with that? No?
Yes. Okay, so so I'm going to start already. So the problem of addressing the problem, this is what I'm going to talk about first. So the study of consciousness is notorious for vague definitions. People fight over vague definitions all day long, and this is across the spectrum. So I'm going to start by saying we all sense the mystery about it, but I'm not quite sure what the useful questions to probe the fundamentals are. So in this talk, I'm going to develop my own definitions that I hope some of you will agree with, some convergence with accepted jargon and with layman English for my definitions. Now, in terms of the definitions, I'll formulate the questions that I think are important to ask, and I'm going to try to answer at least one of the questions explicitly with a computer program that demonstrates a proof of concept of what a full answer would probably look like. Okay. Now, the field is also notorious for losing people to New Age voodoo thinking, getting stuck on philosophical traditions instead of what is empirically true, or looking at it, and misinterpretation of quantum mechanics and people like Deepak Chopra. Okay, so I'm not interested in that. So my intellectual principles in trying to break new ground is, one, there exists natural explanations for all things that we can see, for phenomenal observations, and it is accessible by observation and reason. I'm going to rely, when it is absolutely impossible to go forward without experimental observational evidence or deduction, we can rely on a little bit of reasonable induction to say, okay, if things work on this scale, if the same thing scaled up could probably work. Abstract reasoning into the core of physics may be warranted, but if not, don't go there. Don't say stuff like, quantum mechanics needs to be revised, or GR needs to be revised. If you don't need to do that, don't go there. And the final principle, what I cannot make, I do not understand. Okay. So if you cannot make, this is not a strict principle. This is just to convince you when you say I understand something. That's my criteria, more or less. So definitions, consciousness, that's the broadest and most useless word to describe the phenomena. It's something that we all have, but we cannot be sure that other organizations of matter has, like frogs or plants have. We can just be sure, okay, I have it. Probably by induction, most other people have it. It looks like they're the same. And so I would say a reasonable assumption is animal life forms experience this phenomena on a continuum. Like, little animals don't experience it as much, maybe we do, at a more refined level. Now the next thing is the self. So this is the central point of observation, the sense of I, the ego, or while broadly defined, that which is not the universe, the local identity that is looking out there. These are concepts like the uniqueness of self and the continuity of self. So we get up in the morning and we say, okay, we are the same person that we went to bed. That's the continuity of the self. And the uniqueness is, I am this one, this instant, this is it, this is me. if I wake up the next day with a different set of memories, I don't know if I can say that I'm the other person. It feels unique. Like if someone says I'm going to copy you on Mars, molecule by molecule down to the atomic level, and I'm going to behead you and say that you're transported there, you wouldn't do that. You would say, no, I am uniquely me. Okay, that sounds crazy to me. So that's the uniqueness. Then the next question is experience. I call it experience. I think a lot of philosophers call it qualia, which is the deeply subjective, private taste of what is being perceived. It is what it is to feel the color red. And this is highly debated. If qualia exists or not, people fight over that. I think it does. And I'm not going to address this in my talk. I think that's a very deep question. Cognition is what I call intelligence. It's basically processing sensory information to your output. And agency is another concept, which is the sense of volition, free will. The idea that we have that we can make a decision and move physical objects independent of our hysteresis, independent of physical history. So, for example, automatons don't have agency. That's a tautological statement. If something is an automaton, if you take a chain and you whip one side of the chain, the other side is going to go out there, and there's no agency in this. This is just cause and effect straight. So that's what I call agency. Now, with these definitions, I think these are the main questions that I would like to answer in my lifetime. What is the self? How does it work? How did it come about? And this is my big thesis. My thesis is this, what I call the self, that looks around, that smells the world, is nothing more than a pattern of information. It's a configuration of neural network in the brain. It's a very particular configuration of neural network in the brain of most animals that delineates the I from the not I. It is just software. I don't want to call it software because software implies a Turing machine. Our brains are not Turing machines, are not general purpose computers. They are neural networks. So I'm just saying these are NN-ware, like neural network-ware. It's a configuration of neural networks. It's in between hardware and software that does this thing.
Can we explain a little bit in more details what's the difference between neural machine and just a regular Turing machine?
Sure.
I mean, it's kind of still have an input, have an output, and have a processing part.
Yes, yes. So a Turing machine, in the most general sense, is a series of instructions applied on a series of bits. So what Turing thought is you have a strip, and you have an instruction on a strip, and there's a program that says, put 1 bit here, move 5 bits there, put 2 bits there, move 5 bits there, etc. That's a series of instructions. Now, neural networks, can I draw here? I think I can. So neural networks, of course, I'm actually going to talk about neural networks entirely. So the idea is, so you have some inputs. These are typically numbers, like real numbers. And then artificial neural networks will basically, so these are what you call neurons, and some of them could be, so this number, let's say 1.54, is multiplied by this weight 1, which is, weight 1 equal to 0.8, and then 1.54 is multiplied by 0.8, it comes here, it becomes 1 point something, and then it goes to another neuron, etc., till it comes to the output layers, which is another set of, output. Okay, so you have a set of inputs and you have a set of outputs.
Yeah, but this was my question. Isn't it just a, let's say, regular Turing machine which instead of working on a one-dimensional array of input, it just take a multi-dimensional array? I mean, basically, it's a, maybe I'm wrong, but in my understanding, neural networks is nothing but just a set of different equations which is set it up on a certain grid, which in my understanding completely...
So I think she wants to answer the question.
I'm sorry, I just wanted to comment on this question. So the beauty of neural network, why thousands of people are using it for data analysis, is that it can learn. By learning, it can learn. And Turing is just like...
What's the conceptual difference between this and the Turing machine? Because like if what you're saying, it's just 1D initial array of data or multidimensional, if this is a difference, this is okay. If when you say Turing machine, it doesn't imply that it should be one-dimensional input, then it's another Turing machine, right?
No, so the point, of course, is that this thing, there are algorithms that make it learn, right?
No, I'm not even talking about algorithm. Like Turing machine can I mean, why I cannot reproduce what you said with
No,
a
no.
Turing
So,
machine?
for example, a general purpose machine can reproduce an
So-
ANN. It can reproduce an ANN, but the philosophies are totally different of computation. The philosophy of computation is different. You understand? So what I claim is that this neural network, whatever this neural network is, it emerged as purely a survival mechanism through natural selection in animals with nervous systems. That's the thesis of my talk. That this self that there is just coming through natural selection. And my conjecture, which I cannot prove right off the bat, but I can suggest it's true, is that higher primates like us have a recursive awareness of self that occurs due to a layering of this neural network over evolution. And this is through an arms race of survival strategies.
You're going to prove this, or you?
So I'm
or
going to
those
only
are
prove
your
this part.
axioms?
This,
already?
this is what I'm going to prove. This is my thesis. And this is the more speculative thesis. This I'm going to more or less try to prove harsh. How does qualia work? That's the other question. I don't want to go into that. This is what Schrodinger had to say. I think he's wrong, but that's a different talk. Okay, so now I come straight to my neural network that I have. Now I try to create an artificial neural network with completely random connections between neurons and having no a priori structure. Okay, so let's see. So this, as I do there, is a traditional neural network. You have a set of input layers, hidden units, and output units. And then this is trained in some supervised or unsupervised way. You give it some outputs, you expect some, you give it some inputs, you expect some outputs. If the output is not what the input is, you hurt the neural network. You don't hurt it. You train it. You recalibrate the weights so that it gets the right output. That's how you traditionally do it. Now what I am doing is, first of all, my neural network it is chaotic. So the first neuron is connected randomly to this one and maybe to this one with random weights. Okay, it's just completely random. So if two neurons are connected in this thing, they have two parameters, a distance parameter between them that is a double from 0 to 1, and this tells me this is a non-directed number. It's a 0, 1. To me, it's the physical distance between the neurons. Are the neurons connected or not? How well are they connected? And then there's the second parameter, which is the synaptic weight. Okay, and these two things evolve differently. The distance parameter evolves when the brain makes a copy of itself, when it makes a baby. And that's to say that the brain is mutating. The distances in the brain is mutating. The hardwiring is mutating. The synaptic weights are changing within a lifetime. So to create memories, to learn something new, or to do anything, those things fluctuate within a lifetime. Now,
both of these are continuous variables between 0 and 1.
yes.
So there's a measure.
It's a measure, yes. So except the synaptic weight is directional. It's like saying A to B could have a 0.1, but B to A could have 0.001. Whereas distance is just one number between the two things.
Is there any rule how you define the synaptic weight back and forth?
That is also random.
I mean,
start with this
it's the same synaptic weight, but back and forth they're not connected completely. It's two separate
numbers, and I'm going to talk about how those things evolve. So now what I do is to take this completely random brain and hook it up to on-screen bots whose field of vision feeds into some input neurons. So you will see on the next slide. Let me just go to the next slide. Boy. Yeah. So every one of these little critters out there is connected to a 30-neuron brain. That is complete mush. I don't know if you can see it, they have a certain field of vision. And depending on whether or not these things fall into the field of vision, some of its sensory neurons are triggered. So if a piece of food falls in within 30 units of this, one certain neuron is triggered. If it falls within 30 and 60, another neuron is triggered. If it is beyond 60, another neuron is triggered. And I think there's actually 4 neurons that are triggered by the fact, if they see anything within their field of vision. Okay? Now, they also have motor neurons. They have 4 motor neurons in the brain. So if one of the motor neuron fires, it takes 1 step forward. If the other one fires, it takes 1 step back. If another one fires, it takes 0.1 radian to the left. Another one fires, it takes 0.1 radian to the right. So by hitting these neurons quickly, it can move around like that. Okay. So initially, of course, the brains are mush. There's no correlation between what it sees and what it does. And Now, what I do is, this is the rule. If the bot bumps into a food by accident, a copy of the bot is made with small random mutations in the distance parameters. So this means that the structure of the brain is slightly mutated when it goes to the next generation. No incentive is given to the bot. The bot doesn't even know it made a baby. It just doesn't know. It is not given any reward. It is not being trained in that sense. And once it makes a new baby bot, the oldest bot in the group has to die in order to maintain population and not kill my CPU. All right, so that's the rules. I'm going to go through a little more details, and then we're going to look at this stuff running, and you guys can suggest how many starting neurons to have, and you can actually start playing with this thing. So synaptic weights. How does that evolve? So synaptic weights are reinforced or decayed exponentially within a lifetime based on use of connection. So if that particular connection is being fired, the synaptic weight is charged up like a capacitor, like e to the power of minus decay constant times the impulse. And if the synaptic weight is not being used, the weight slowly degrades. It's just like in our brains. You can make a memory, you can forget a memory. So then the next thing I want to say is this brain is time stepped. So it is for time for t equal to 1, the impulse goes from here to here, everything goes one way. Next impulse, the impulse goes next impulse goes next, etc. So it's time stepped with the same time as the actual the world simulation as well. So this, so neuron fires after firing the sum goes to 0. Oh yeah, so it has an action potential as well, just like our neurons have. If the sum of the inputs goes beyond the threshold, the neuron fires, and then it goes back to 0, and then it waits for the inputs to climb up again, and goes and crosses the potential, fires to the next neurons. That's what it's doing. Okay, so let's see. So the time step nature allows time signature inputs and sophisticated motions. So you can have time signature input like input 0, 1, 0, 0, 1 means something to the brain, and output 1, 2, 3, 4 means a certain kind of motion to the brain. So it can be time signature. Also, feedback loops are possible to be generated inside the brain because they are completely random, which I think is some sort of a proto-memory. I don't know what it is, if those things come about. And what I claim is that sophisticated neural network wear arises from these principles that makes these bots look for survival, even though each one of them is not told to survive. So I think these are like ancient versions of itself that come about. And this, so let's start. Okay. So there are some mutation parameters you need to give for evolution, so every time a new bot is made, it can get one brain cell. There's a certain probability that you can get a new neuron, or that you throw away a neuron. It's a mutation parameter. Then there's another mutation parameter that changes whether or not a connection is just randomly severed, or another new connection is randomly put out there. It's a mutation parameter which is a small number, much less than 1. And these are things that can be tweaked. And there's another mutation parameter that changes the strength of the distance connections. Again, with a Gaussian blur, very, very small parameter. And that takes you to the next generation. Okay. All right, so let's watch a live demo of this. So, let's see. Okay, I'm just going to copy paste. So let's do this. What? Sorry. Oh, okay. I didn't copy the whole thing. My bad. All the way minus n foods, minus n predators, all of it. I'm not sure. Shouldn't do this one. You can almost understand my code. There's a neuron class, there's a brain class, there's a bot class. It's pretty transparent actually. So N foods, how much food should I give it? Let's give it 10 food. And how many predators should I make? Predators, I'm not going to talk about predators yet. The predators are basically bots with the same brain, but they run after the bots. Okay, alright, it's going to start now. So, I think it's slow because QuickTime is running. Okay. So I'm rendering every 10 time steps. Okay, so now you can see them very slowly. You can convince yourself that they're pretty dumb. They can look at food and they just don't know what to do about it. They're just going to spin around. Look at that guy looking at food. He's just mush. The brain is mush at this point. Okay. So I'm going to speed this up a little bit, 5 times, and then you can see how this works. So time step, revolution. Let's say I'm going to render it every 100 time steps. All right. So n bots. Let me put a few more bots. Let me put food is 10 is good. Alright, so initially again, they're pretty stupid. I think the problem is QuickTime is running on this machine to get the talk, and that's why it's not being fast enough. Do you think we could stop QuickTime and then start it again once the thing starts? Yes. Is it okay?
Mm-hmm. It's in the menu bar at the top.
Oh.
Nope, to the right. There's a stop button among the small icons at the top right.
Okay.
Yeah.
Alright, there you go. Sorry. Oh, what the hell? Okay, alright. So now it's definitely faster. So you can see some of them actually figured out that if there's something out there. Look at that. Look at that guy. He's figured that out. So he's going to make more babies. But he himself doesn't know that he's not running after food. And now you can see the idea of common ancestors. They are swirling because they all come from the same bot who had a tendency of doing this. And why would they swirl? They're swirling because they're moving their radars around. Every time they eat food, they still want to look around for new food out there.
They don't see each other, right?
They don't see each other. I could actually I was thinking of putting that in, but I think it's first case simplicity, they don't see each other. Now, after a while, you'll see this speed up to a frenzy, and if you think about it, they're really competing with their own offspring. So you will see crazy survival behavior just running after the things to catch them.
So the lines of their field of view or something?
Yes, that's the field of view. Yes, I did. That's it, yeah.
I feel there's one that just goes backwards.
Yeah, so that's going to die pretty soon, yeah. So so look at that, that's a different strategy. They're bumping off the walls, so by accident they'll bump into some of these stuff. Some of them are doing the swirling, some of them are doing the bumping, walking backwards and bumping. And they're just as useful as the other. Alright. Yeah, look at these guys, they're just... So they're kind of bump. So they're a good strategy too. This guy is swirling. These guys are bumping around the walls, and they're two independent species almost of brains out there. Some of them win, some of them don't. Okay. So if you looked at this enough, so now we can make some plots of what's actually happening in the brains. So this is just generation 200. Once you go to generation 1000, things go real crazy. I mean, you will see really interesting stuff. So let's see where am I. So, boy. Oh, no, sorry. Why is my PowerPoint dead?
And climbing up the walls.
Oh, this is the QuickTime. Oh, God. Yeah, I see. This is my PowerPoint. So we've convinced ourselves that initially they're pretty dumb. They take 1 step forward, 2 steps back. Eventually, you can speed it up, right? So this competitive behavior emerges. And what I want to say is no incentive exists from the point of view of an individual bot. It doesn't even know it's reproduced. How does this emerge? Hint, a daughter bot exists only because its parent bot had some tendency to hit food. That is, some wiring in the brain correlated food in the field of vision to firing motor neurons just so as to reach it. And this correlation is amplified. Can you see the common ancestor behavior? This is a pretty cool one. So if I put the debug equal to 1, you can see all the names of the bots. And you can see that everyone has its parent's name appended to it, so you can see like they all come from bot number 8, second child, third granddaughter, and they're all. But yeah. So now what I say is, right off the bat, it seems behavior suggestive of self-preservation emerges as the bots begin to compete with their offspring. So now, what do I have next? Okay. So now is the main money slide. So if I were to use, let's see whether it is right now. Okay. So now it's pretty obvious. I mean, they are trying to find the fastest solutions possible to getting food and also finding food. So now you can make a plot of, which I did, of the amount of time. So the amount of time it takes to get to the next meal versus the number of generations. And this is something I made, it takes a while to run. You put 20 plots on the thing, and you see, so this is a log versus log plot. So it's a rapid decrease, it's a 1 over generations. The time comes down, and eventually it asymptotes. Now you can also ask what the average size of brains are. So it starts with 30 neurons, and this is generations on the x-axis. So then it figures out, well, I need 45 neurons to do this, to solve this problem. But then it suddenly drops, and the reason it drops is 2 reasons I figured out. So it happens if you don't have enough bots on the screen. So evolution is blind. It can easily fluctuate into a point where everybody is pretty dumb. I mean, if everybody in the group is dumb, then there's again no incentive to go forward. If they all inherit from the same idiot and they happen to be good at it, I mean, that idiot happened to have 5 babies just like that, then you're screwed. So we try to use more number of bots in a bigger world for at least meaningful plots. So that's typically what, and there's actually the other incentive for having a smaller brain is you can get smaller connections between the input and the output, and a smaller chain of connections. And that means it takes lesser time. As I said, the brain is time-stepped. So it takes lesser time for them to see something and then to react. So you see some kind of pruning behavior when that happens. So it prunes itself.
Sorry, the right-hand plot is generated for one particular initial state, is that correct?
Yes, that is right.
And if you start with a different initial state, you'll get the same sort of pattern?
So no, you won't. You will get a different kind of pattern.
But do you think the final asymptotic should be the same?
It should be, yes, it should be.
So let's say, or maybe it's few different values of
right. In fact, I
brain
have a
size
plot.
it can fall to.
Yes, so in fact I have a plot which is done with a few ensembles, and then you can see pretty much asymptotes. But then the little S curves inside the asymptote, that is also very interesting. And that actually is a little like punctuated equilibrium. It figures out a solution, is successful for a while, then some offspring just realizes, oh, I need one more brain cell to get this one better solution. And then everybody becomes a son of that offspring. So kind of like the brain cells kind of go up, S curve, and then asymptotes. And that's another interesting behavior. So what I want to say is the blind watchmaker of evolution makes a watch here. So that is the thing. Okay, so I think we have some time to introduce predators. So this is another interesting part of it. So this is where an arms race takes off. You put in bots that go after food, now you put in predators that go after the bots, each with the same kind of brain, and you let them go. Now you see the bots will actually try to avoid the predators and get the food. When they come near the bots, when the bots come near the predators, they kind of step back. And then they try to look around and they go after food. And this is another interesting behavior. Wait, I should turn on the QuickTime. How do I turn on the QuickTime now?
You can just minimize it.
Is it running? Is the QuickTime running?
No, you have to start a new recording on the file menu.
So
Screen
new
recording. No, the screen recording.
Oh, jeez. Stop. Oh, new recording? Okay. Alright.
Button.
Oh, and you have to press the record button.
Sorry, I've never used this thing. Okay, so as I said, predators can see and eat bots, bots can see predators and food. And so now we can try a live demo again with 100 time steps of what happens if I do that. But let's see how far things have gotten. So So these guys are now pretty good doing cool stuff. And let me make a plot. So I have plotting scripts. And these are pretty much the same plots as I was showing you. Oh, so quick time is running. So, this is, okay, so for example, this one, you see what I was saying, it goes up, figures out a solution, then another kid realizes, oh, I can get a better solution with a new neuron. Keeps going up. So, that's one
So
thing.
with the predator?
Oh, there is no predator in this situation. So it's just a
Okay.
legend, there's no predator. It's my plots. Stupid.
That's
Generation. So this is the time. So this is the average time for the next meal versus generation. This is what I was showing on. So you see? So
It's
it
like
falls-
order of magnitude decrease, right?
Yes, an order of magnitude decrease and in steps. Figures out a solution, figures out a better solution, figures out an asymptotic solution. So anyway, this is really interesting to just look at and enjoy.
Degradation never happens, no?
Huh?
Degradation never happens.
Degradation.
Degradation. So again, more time is required.
Oh, sometimes it happens. If you just have like 5 bots in the screen,
Ah,
yes, it'll go back up. It'll say, oh, I found some idiot reproduced. Yeah. Okay, so now let's try. I have some time actually. So brain inward with predators. So go back here. So brain inward. Let's see what was my suggestion. So time steps 100, 200, 20 bots, 10 food, 5 predators. So the predators are not going to be that smart, but you can see something cool. Right? So 20, 10, 5. Yes, yes. Okay. So, right, so I think I need to stop QuickTime one more time. Okay. So now you can, after some time, you will visually see this happening, that they start to run away from predators. Oh, yeah. It's pretty hard to.
But the predators multiply,
Did they
right?
ever
The
try to
predators
beat
must-
the predator?
Huh?
Did they ever try to beat the predator?
Yes, eventually they beat the predator.
Okay.
Yes, so eventually, so so this is something I did over the weekend. So this is very, very, very new stuff for me as well. So look, so first of all, these guys are figuring out the swirling motion. Eventually, they will have an arms race of brain cells, and they eventually outsmart the predators. And I figured out giving the predators and the prey the equal speed means the predators will almost always be outwitted, because the prey started to train before. So their arms race began before the predators.
Maybe it's also related to relative speeds of food drift and the bot drift, because in this sense they kind of similar to each other.
Right.
I mean, the bot which trying to catch the food and the predator which trying to catch
Catch the bot.
catch the bot, but
Eventually the bots speed up.
obviously
Yes,
you have a different drifts here
Yes,
of green
you're right.
dots and blue, so
you're right.
it also might be a difference why they can.
Why they cannot catch up anymore.
Mhm.
Yes. Yes, absolutely. Yes, I didn't think of that, but yeah, that is definitely a situation.
And I mean, not just speed, but also, as you said, they can maneuver in around predators. So
Yes, in fact, they start doing that. They will look at a predator and move around it. Oh, look at that. Do you see that? You saw?
Yeah.
Yeah, so they start to like avoid as much as they can, but the predators are also out there to get them. So this goes on for a while, and if I So this time step is just the rendering. The program spent most of the time rendering on my T canvas. This is entirely a root T canvas, and that's why it's just very.
A whole lot of bots were ganging up on each other. I mean, becoming coherent somehow. They all seem to be going.
Because when they have a baby, the baby is happening at the same spot. So if a bunch of the bots got eaten together, a lot of the old bots the old bot gets to make a lot of babies. Maybe that's not a good idea. That's my program so far. Yeah. So let me get to the conclusion. So I am gonna assume. So let's see. So an AI arms race develops. So these are the results from 1,000 world site, 50 bots, 50 food, 20 predators. So there's enough diversity to go after as much as you can, to go after time as much as you can. So bots appear to avoid predators in search for food. Predators learn to stalk the food of the prey because the predators know that the prey is going to come after the food. So they kind of swirl around near the food. So when that happens, the predators learn, and also the predators learn to swirl in the opposite direction of the food, of the bot. So the bots are swirling in the clockwise. The predators know that, oh, I can do that. Then the prey realize, and then they go the other way. So it keeps oscillating sometimes. And so the time it takes for the bots to eat food drops. The time it takes for the predators to eat food drops. And this is the arms race. That's the money plot that I have here. The average size of brains starts to shoot up both ways. Okay. Now, what I say is that looking closely at the behavior of the bots, if I were not to tell you anything else about how it came, if you just walked into the door now, you would say, well, those things are really kind of trying to survive. Isn't that? Are they trying not to? They're doing self-preservation behavior, which implies an understanding of the existence of the self. Some very proto-self is coming up. Some very, very proto. It's not. And the bots are taking that self-preservation very importantly.
But this is a rather arbitrary statement, right?
Yes. So yes, it is a bit of an arbitrary statement, but this is hard to quantify. I wouldn't know how to quantify this. That it looks like they're trying to self-preserve, which implies that there is a self in their brain somehow.
We have laws of preservation just in simple physical dynamical systems. Integrals of motions are preserved, but we are not concluding that.
Like what?
In dynamical systems, integrals of motions are preserved, but we do not conclude from that that the physical system has self-awareness.
You mean symmetries of motion, like
Sometimes integrals of motion. From the preservation of whatever, we normally do not conclude that the self exists there. That's two different things. But okay, I do not want to discontinue.
Because this one evolves, that one is fundamentally true. Okay. Now the question is, what about the self-awareness that I know and love in the world that I see? Now my conjecture, this is completely conjecture, is based on this. So out here in this system, the natural selection environment is very simple, so we can understand the basic principle of the system. More complicated game worlds like the world would, I think, yield sophisticated survival strategies. And you add predators to the system and other pitfalls, a layered version of the self can emerge. What I think happens is you look at the world, and a lizard brain or a very limbic, a very old brain would look at it, and there would be a reflex arc from the sensory neuron to some sort of neural network where, just like this, the lizard would just try to survive. You have an input, you have an output. You have the food coming out, snap at the food. Very straightforward. Next, what I think happens is, and this is something I cannot demonstrate at all, except from some suggestive thing from experiment. I think there's other layers that emerge that take the state of this neural network itself as an input and then inhibits its output. And this is what I would say is like what a mammal or something like that would do. It knows it is hungry, but it won't act. I mean, it is aware it is hungry, so it won't act on it right off the bat because there could be predators around. So you take in more information to make instead of having a simple reflex arc, it becomes a more complicated reflex arc. And I think that is what this kind of layering eventually leads to how we observe the world. And this kind of hunch is also kind of structurally mirrored by evolution. You know, we have the reptilian brain under it, we have the mammalian feeling brain over it, and then there's the neocortex that's over it. And what is even more interesting is what I saw, and I think we identify with the highest layers of this self, of this NN-aware as a self. This is an article on the internet I was just reading yesterday. So they have now begun to really deconstruct the brain in this thing called connectomics, where they literally take a rat brain and they try to find out how it's mapped. And so they say with more comprehensive picture of how neurons connect with each other, they have discovered local networks of neurons layered like the shells in a Russian nesting doll. Two local networks, one governing vision and learning, the other tapped into the bodily concerns like muscle and organ function, make up the inner shell of the rat's cerebral cortex. Two others, one governing smell and another, that assembles and makes sense of the information from the other three networks, make up the outer shell. So I think there's this shelling behavior that probably goes on, and where each part of each element, each shell is a very simple thing, something like this neural network, something like this kind of neural network. And this is completely conjecture. I think this is what eventually gives rise to what we have up here. So, of course, you don't know if layering happens or not unless you open up these AI brains, the brains that are developing. And this is completely in the works. Right, this is developed over yesterday or the day before yesterday. I don't know how to measure structure. How do you measure structure in these networks? It's an open question. You guys can tell me. How do I detect loops in networks? I think there are algorithms that exist that do this. I don't know them. How can I detect layering, if any? Okay. Now, very basic, what I can do, for example, is I plot a histogram of the distance parameters. And initially, it's some kind of mush, which is like, this is basic initialization. After a few 10,000 generations, you have an exponential fall. Eventually, I see, for example, this means that each cell is connected to 8 other cells, or between 4 to 12 other cells. So it goes away from there's some definite structure that's emerging in this brain. I just don't know how to look at it. Okay.
And you have a lot of cells that aren't connected to any others.
Exactly. And so so a lot of cells are just sitting around. I don't know why they haven't been pruned by evolution, but they're just sitting around. So this has to be studied.
Just because they're disconnected, does that mean they don't serve a function?
Yeah.
Why?
Well, they're just sitting around. They don't connect. They don't talk to anybody. So these are.
So they don't connect. I mean, there's inputs and outputs.
Right. So
are they not connected to the inputs or outputs?
So the way I have it is, so I actually I look at every neuron and I say, who are you talking to? And it tells me all the distances between the thing. And I say, okay, add up all your distances, even though they're weights, they're numbers from 0 to 1. Add up all your things and just plot it out this. I think I'm plotting int out here as well, so there could be some structure even inside that. But I think there's a lot of neurons who just happen to get disconnected over evolution. They're not good for doing anything, but then evolution doesn't care to take them out either.
There's no cost.
There's no cost. Yeah, so I don't have a cost to this. Yeah.
So you can put in some like energy consumption.
Right, I've thought of that. Yes, that makes the system a little more complicated and the rules a little more complicated. Yes. So yeah, so that would probably prune away these dumb ones. So anyway, this structure needs to be studied. I don't know what the hell is going on in there. So, but for example, so this is again something I discovered yesterday, is that these people in neuroscience are now starting to make distance maps, just like I had distance maps.
Analogy of recurrent plot?
So, yeah.
Is it the analogy of recurrent plot?
Yes, this is experimental from a rat brain. 73 neurons times 73 neurons slice of a rat brain. Now again, I don't know, I have to try and think about how to analyze this thing. This is on Excel spreadsheets. So if I can show that they have similar structures like I have after 100,000 generations, I can start making some real flames out here. So this is just, has to be studied. Okay, last 10 minutes. I can't delve on this a lot, but ethical implications of, if I were to really take this seriously, that the self, and if I really accept that if the self is nothing more than an information system, and its elementary, unique, and continuous nature, no more than an illusion put in place by evolution, what does it mean for our moral arts? It completely recalibrates a lot. Academic understanding is cool, but actually internalizing this can be unnerving, since our ambitions, hopes, and entire lives are centered around the self. The self is important. So to me, having thought of it for many years, when I first started to really think, maybe this is true, I felt a complete loss of center. It's like, it's a humiliation of the ego that I think is comparable to our insights of heliocentricity when we were no longer the centers of the universe, when we realized, oh, we're just another planet out there, you know, there's a lot of things. And evolutionary biology that taught us that we are just one of many other animals, many other solutions to the evolutionary question. It is a bit unnerving to understand this. And for me, it has recalibrated the way I look at the world, I see people, because, for example, I can say that, you know, Alexei's experience of the self is fundamentally of the same nature as my experience of the self. He has different memories, he has different trajectory in life, but the self-experience is the same experience that's going on there. So I think this gives rise to a radically different form of empathy. To say that, okay, all of them are different instances of the same kind of mechanism, okay? The suffering and the pain that I feel in life is similar qualitatively to the suffering and the pain that others feel. So there's no reason for me to go out and hurt other people or to do to do bad things. It's a radically different form of empathy that arises, where you begin to identify with the other self. So I say that through my years, with the self, if you really see through the self, you can relax and you can say, okay, let the universe work through it, because there is no I. The universe is doing this whole thing, and it's creating it's popping up little things that say I am, and they're all saying that because they're products of biology, and at the end of the day, it's just going on. So I'm saying, so I just like this image of Alex Gray. I think the whole the metaphor of Adam and Eve is actually one where it's a metaphor for, I think it's a metaphor for the creation of the self. It's a metaphor for separation from God, or separation from the universe. It's like saying I am suddenly aware that I am, and I am separate from this whole wonderful thing that's going on, and I need to take care, I need to grab my food, I need to find my place in the world, the clinginess that comes up. And I think having this understanding and really getting into it, if you really want to get it, with the ego seen but not denied, the separation from the world undoes itself. It's kind of, you undo the original sin. But I don't believe any of that, so I just think it's a cute metaphor. So conclusion, I think I'm just in time. So I want to say that the study of consciousness is pretty much where classical mechanics was when FP, MA were being rigorously defined and the relationships understood. A conjecture, I think, maybe on solid ground, is that I can say any part of the universe that experiences itself or claims to experience itself has undergone selection to survival of the fittest.
So I think it was very good, interesting talk, and maybe we have 10 minutes more, maybe we just briefly asking questions, but please, asking your question, please remember about other people who also want to ask, so please be reasonably shorter.
So
yeah, I'll be sticking around here for another 5
Can I go back to my first question? Because
yes.
Based on your comment, things that they haven't been understood. So I will try to reformulate it real quick. So there is a mathematical discipline called dynamical system theory. This discipline studies mainly two objects. It's differential equations and difference equations. It doesn't really matter how big your phase space, how many degrees of freedom you have, and are you solving, these systems on a grid or like in, continuous media. It doesn't really matter. It's a complete deterministic models which can show some patterns appearing, like, some self-organization, which has nothing to do with self-education. So it's a pseudo-self-education. Even if you don't have a genetic algorithm, probably this is what you try to comment, genetic algorithms, not a difference equation or solutions on a lattice. I mean, this part has nothing to do with genetic algorithms.
You're right, it doesn't.
Exactly.
This is put inside a genetic
And what I'm trying to say is that at the beginning of your talk, you did two statements, one after another one. The first statement was that probably our brain has nothing to do with the Turing machine. And I probably will agree with this statement just because in my understanding, this is a very personal feeling, but your brain feels things around you in an analog way, not in a digital way. When you say in triangle, you really know that you're talking about any type of triangle. You never digitize and specify this. While all objects from dynamical system theory, it's a digital objects, and they can directly be simulated using our real Turing machine, which is a computer, including the genetic algorithms, including everything. And this is just a part of dynamical system theory. So again, is there any
really important difference between like this and the Turing machine? Because in my understanding, it's
Okay.
again a
Yes,
digital deterministic
so
system.
from here, you can get the idea of the letter A.
Yeah, of
These
course,
kind of things can
course.
encode the idea of a letter A or the idea of a triangle. For example, character recognition with deep learning does that these days. There is such a thing as an idea of a thing, which can get encoded out here.
But it's not analog, it's digital, by definition.
What is?
This type of different, I mean, basically this is just a difference equation, where some parameters can be, let's say, under the noise, like a deterministic system plus some stochastic noise on top of it. And it's still, in this sense, deterministic system, because
Yes,
you
it
have
is
a...
deterministic, yes, it is 100% deterministic. That I'm not doubting that.
But I mean, then it's a kind of Turing machine. I mean, your
So
brain,
it can be
what I'm
simulated by
trying
Turing
to
machine.
understand that is brain, your model of brain, is
Okay,
a
maybe I'm
Turing,
saying, okay,
Turing system if
okay.
you take this definition very precisely.
I think what I'm saying, I probably misspoke. It can be modeled by a Turing machine, and therefore everything that this can do, a Turing machine can do. If the very fact that I can
Then it's
simulate it,
okay.
yes. I think I meant to say it's not a von Neumann architecture like CPU. It's not something with a RAM.
No, yeah, of course, of course.
Yes, that's
of
what I
course.
meant. Yes.
For Neumann, it's a different thing. But Turing
Yes.
machine and, you know, there is experiments
Yes.
when people really trying to see, is your brain a Turing machine?
Right,
or
right. And I think, yes,
Okay.
it can be simulated by Turing
Thank
machine.
you.
You're right. I think you're right. I agree on that.
I have a question.
Yes.
You should present a certain view that consciousness emerges from pursuit of food. So would you
Pursuit
say...
of reproduction, actually, is the pursuit of the propagation of the gene. If food is the point, that if food is what allows that to happen, then that's it. But I just call it food out here. But it's whatever it is that triggers the reproduction.
So would you say that your desire for food or reproduction, as it grows, the theory that you're presenting becomes more true?
Yes, I would say, yeah, the theory that I'm presenting becomes more true as the food, I'm not sure.
The hungrier you get, will the theory that you're presenting become more true?
The theory is the theory. Are you saying the response will become more true?
No, the ideas that you have presented.
That you're hungry.
I think you'll have to crystallize the question a little more, like, what do you mean by the theory becoming more true?
Well, you have made some statements,
Yes.
and these statements can be true or false. Now, the hungrier you get, will those statements become more true or more false? I mean, if you're less hungry, will it
arises
become
from-
false?
The bots
if
are
you're
not hungry.
The bots are not hungry initially. The bots become hungry for something.
So if you become more hungry for something, will it become more true then? Or?
Well, hungry is what is emerging.
Mhm.
Hunger is part of the conscious thing that I'm saying, is that the self's drive for stuff, which is what you would call hunger, the self's drive for food is what you call hunger, is something that that I think would be, yes. But I'm not sure. It co-evolves. The hunger co-evolves with their ability to get more food, right? Like the hunger co-evolves with the brain lining up to feel hunger, to feel a need for survival.
Yes, but if one of those dots develops some sort of a picture of what this whole thing is,
Mm-hmm.
will that picture actually have any chance of corresponding to reality as long as it finds its food?
Yeah, so you're saying, so yes, yes, it will. So it is mapping out its objective reality in some way, very, very vaguely initially. Initially, it has zero concept of what its objective reality is. Eventually, I don't know, maybe some part of the brain says, I know a certain way to respond to this food. So it kind of starts to know, okay, when I see that flash in my neural system, that corresponds to something. But, sorry, do you have, let me finish answering this question. So I think, yes, I think it starts to make some map of reality in there.
But okay, so last time we talked, I had an idea about this, that there's definitely two things that we call consciousness, and you can argue that those things are actually one thing, but there's one kind of consciousness is when we say, you know, an animal gets hit by a car or it's sleeping, and then it's unconscious, and when it's running around and barking, then it's conscious. But a whole different other kind of consciousness is the consciousness that can come up with theories of the universe and consciousness that can hold the truth, the consciousness that has the first-person self-referential experience, and things like that.
I think the first-person self-referential experience only comes from these things. It doesn't come. It cannot just be that. I think.
But I mean, in this case, don't you think that showing your graphs and simulations, sometimes you can kind of figure out that, let's say, new type of behavior appeared, right? As you saw, like one strategy appeared, and you know, guys doing one thing, then another strategy appear, and you see another bump or another substructure on those plots. So don't you think that in this case, if your initial bots, who definitely have no any self-awareness and self-consciousness, at a certain moment that your simulation will obtain it, then you should be like an indicator that, okay, I have a new bump, a new substructure, like my creature is going to the whole
I don't know. I don't know. But that is something I will have to figure out. I don't know.
Be fair, guys.
But I mean, don't you think that will appear?
I don't think it's not going to be a delta function. It is going to be, I think, a continuum over which such things will evolve.
Okay, we will have one more, or even two more chances. So guys, be fair and do not ask too many questions. Let other people ask. Mike, please.
So when we see these animations, we think, like ants,
Yes.
right? Which is very simple, very interesting. But I'm wondering about, the much higher level.
Okay, can we, Mike, if you have a few minutes, I think she's been waiting for.
I'm sorry.
Oh, I'm sorry, I jumped in.
I just have one technical question.
Yes.
As always, I don't understand much, just technicalities. Is there any parameter, if they wouldn't eat, they will die?
No, there is no such parameter. So they can just be stupid and just sit around and just do this.
Okay.
And that happens.
Gotcha.
Yes.
So I was just wondering about another level where, we have tribes as rather than entities or bots and nations, and they are aggressive nations,
Yes.
and there are
Yes.
wars developed.
Tribalistic.
Okay,
Yes,
so
tribalistic
if one
egos.
could develop with different rules, a sort of analog game of
Yes.
how wars develop between nations. That would be also very interesting.
Yes. Yeah. So yes, I do think, for example, tribal warfare, all of that comes from survival, and then the whole group tries to survive. It's a self-preserving behavior, just like this, but it's much more abstract. Yeah. Yes.
It seems to me that, could self be part of just a more general phenomena of modeling of the external world? You're one component of the external world.
Exactly.
And can you look in your brain for representations of the external reality?
Yes. So I think then the question, I'm just going to go with it. So then the question is, why would the universe do this? Why would it try to map small portions of itself out in another?
Well, is this an efficient way to develop better algorithms?
Why would it do that?
Well, I don't know. In science,
To survive.
In science, we make models of things. That's how we
Right.
understand the world.
Right. Even our brain does that.
Yeah.
Why would a neural system start to do that? And my answer to that is because it needs to survive. It needs to map out an objective reality the most precisely it can, so that it can use it, so that it can make blindly it just makes another of itself. And I think that drive for making a map.
I mean, when I play chess, I imagine different moves, and then I pick the one that's best.
Right.
Thing.
And so I suppose these things
could be doing
after
the
a while
same sort of calculation.
Right. For example, when they run after food and they see a predator out there, they kind of recalibrate. I don't know. Yeah. Can we go? So, for example, I have also noticed another behavior where the predators move backwards, like this, and they bump up the walls. So they kind of figure out from what they see that if they see a stream of bots going this way, they would rather move backwards and bump into the bots. And I think that's like a little higher order thinking. Like it wouldn't occur to me directly. So yeah, I think higher order thinking can emerge in these things.
More questions? If no questions, I have one.
Yeah.
Actually, to my mind, maybe it is continuation of the Tim already talked. To my mind, it is an example of dynamic system. Very complicated, very interesting, showing some evolution patterns, and in the language of dynamic systems, I would call them some attractors.
Mm-hmm.
But and as a dynamic system is, again, it's very interesting. I appreciate your talk, but I do not see even a tiny connection between dynamic systems and self-awareness. For self-awareness, first of all, self should exist, and self has nothing to do with dynamic system, because self my seeing myself at first phase and I even cannot. Of course,
do you
I
think
know
is-
I know that you have the same, but this is knowledge is sort of inborn for me. I know it from my childhood. It was sort of inborn action. I can never prove it. If some strange object will appear here and will behave maybe consciously, maybe not, I do not have scientific way to prove or disprove that conscious is there or not there, or self-awareness is there or not there.
You can
Also, thought is not observable scientifically. I do not know even how to define thought. So my understanding of your talk is that it is dynamic system, but all your speculations about self-awareness, it is, to my mind, it is not grounded in your talk. So
We can observe thoughts scientifically. That's what functional MRIs are.
No, not. It's a little bit different type of
Not
thought.
MRI.
One type of thought is very primitive. Let's say you really want to eat, or you heard somewhere, and you can
Yeah, the
really
same
trace
part of
the
my
active.
brain will light up
Let
every
me
time.
finish. Then you can retrace the activity of certain part of neurons. But let's say the moment when you understood the concept of how to solve a quadratic equation, how you can track this moment when you really got the whole idea of now I can solve arbitrary differential or like equation of quadratic equation, discriminants and whatever. There is no any neurons in your brain which are responsible for solution of quadratic equations or linear equation or
You
understanding
cannot
of
even
concept
repeat that
of
experiment.
matrices.
It
Let's
only
say you
happens
just-
once.
Huh?
You can't even repeat that experiment. I think that's a bit of a stronger argument.
Exactly.
It-
Let's say you
it
just
only
learn the
happens
theory
once
of
in a
matrices,
lifetime.
and you have like the whole concept of what is a matrix, how to add them, how they commute, and whatever. Like this type of
So you
thoughts
understand the
probably,
general
in my
principle?
opinion, might be not trackable,
No,
especially
no,
because
no.
you have no way to repeat this experiment.
No.
I mean, it's scientifically, like by science definition, every experiment should be repeatable, even with supernovas or with particle accelerators, with whatever. This very unique moment when you kind of employ any concept for your life, a new concept, brand new, you had, nothing to do with before, cannot
has
be
to do
tracked.
with
I mean, cannot be repeated first
can't
of all.
say- You can't say
We
cannot
learned how to
be
find
traced.
eigenvectors
I
like
don't-
5 times.
Okay.
So that was repeatable.
No. But once you understood, I understand how to find
No, if you-
eigenvector for any arbitrary matrix. It doesn't really matter how this matrix look like. I know the exact algorithm.
Yeah, but the fact that I learned how to do that 5 times means that it was a repeatable thought.
How do you mean you learned it 5 times? You cannot learn how
I
to
learned
kiss
and
5
forgot
times,
it
it's only once.
4 times.
But it's a different experience. It becomes something else because your previous experience is superimposed onto the new ones.
Yeah,
So it's
that's right.
it's not the same
To
thing.
answer Alexei's question, my conjecture is that the self is just an information system. It is the information system experiencing the world. It's not energy, it's not matter, it's just the information that is looking at stuff.
It's information system you have in your laptop, information system.
Right, but this one is not, this one does not, it doesn't, that's what I'm saying. This laptop is an information system and so is a thermometer. A thermometer that's just measuring something, you can also say it's an information system. It's a stupid, but I'm saying information systems that have this structure of self-preservation are the information systems that have an experience of the self.
You may describe dynamic system in terms, any essentially rather rich dynamical system in terms of information. Some attractors will appear and stay there. You will say, okay, they are surviving and self-preserving and so on. This is all can be expressed in terms of dynamic system language, the attractors, without any references to self-awareness and
But
so
if
on.
there is
And adding to
self-preservation-
Alexei's comment, I will say that this is exactly the way mathematicians do that. When they study in a kind of rich dynamical systems, they really create an atlases of possible types of behavior, just like you do. They just saying, okay, the system is so complicated, it have a million, even like second order differential equations with couple of tricky terms will give you about system with at least 3, 4, 500 solutions, which is possible. And they just create an atlases where they really draw it, like in this area of parameters we have this, in this area of parameters this system will oscillate, in this it will decay, like grow, like whatever. And again, you cannot say that this differential equation with these couple of terms have some type of self-awareness.
No, but if there is
from point of
behavior
view
that
of
is
math-
self-preserving, if it is self-preserving, if it corrects against its own destruction.
You are saying self. You already implying
No,
that
it-
self
right,
is
right,
there,
that's what
but
I'm
you
saying.
should, you are
In this
going to
sense,
prove
they
it. You
imply-
shouldn't
yes,
imply
in
that
this sense,
self
it's just
that
like
is
yes.
there.
It's just a criteria on this atlas. Let's say now I'm not interested in all possible solutions of my differential equation, but I am interested in, let's say, oscillative behavior and decay. I'm not interested in a growth to infinity or whatever. So again, you're not, if you will have now algorithm which will take a differential equation and, you know, take only certain types of behavior which is interested for this particular checker, then, I mean, again, I'm not sure that it's a self-awareness, but...
No, it is not self-awareness. No one's claiming that a differential equation that grows, or a difference equation that keeps growing.
But this is just a difference equation.
No, but this is something that propagates itself. That says, I will survive. If you change something in me, I will unchange it.
In dynamic system, you may have this.
Yes, you can have attraction systems. Yes, this goes into attractions.
So, by means of Occam razor, I would refute all this self-awareness, because I do not need this language at all. Everything, as you actually described us, you described us in terms of dynamic system, how your dynamic system is actually built. And we have actually a consciousness.
No, why do you not think what we look out in the world is such a dynamic system? That is just doing that.
No, you are an author of this dynamic system. This is your consciousness behind this whole order. This dynamic system which you showed us has a creator, and we know, him a little bit.
No, but
you should pray to him.
But I'm not creating an answer. I'm not creating the neural network. The software, the neural network where that comes out is not of my. I don't even understand it. I don't know what's inside. I don't know what the path, what the structure is. I don't know it.
You structured it from the very beginning. You put, as you described us, the laws, how it.
The laws,
how it
yes,
works.
the laws of evolution.
You are a lawgiver, so this system have a law, and then.
It's the same thing as the world has laws, or the environment has laws.
I mean, there's different. This is at the level of ants who have predators and food, and it's like ants. Well, are ants self-aware? I wouldn't say so, but I don't know, of course. But there's the extra levels, mammalian brain, our brain, you know, much more complicated. And at that level, I mean, your game doesn't attempt to.
It doesn't attempt to go there. It doesn't attempt to go there.
It's saying that survival, which obviously, I mean, we have had survival driving us for millions of years, actually. Otherwise, we wouldn't be here, right? In the other universes where the survival instinct wasn't there, they would die out and no people. I mean, so...
Right, so I think something like this happens when,
I mean, I think
systems get
it doesn't prove self-awareness, but it's an interesting aspect of it.
That's for sure.
It's a first pass at what the kind of answers could be like.
Yeah.
I think they are dynamic. I think they are dynamical systems of that. That's all there is to it. There may be all there is to it. Maybe, and then the question of qualia, which is true, which I think is also what I think you are alluding to. The question of qualia. Yes, and I think that's a very tough question.
Even more thought, because self-awareness, I think, the real important thing is thought. We even cannot define thought in terms of a physical world. What is thought?
It's information, like Microsoft Word. What is Microsoft Word? It's just a piece of information. It's not the hardware. It's not.
I'm not saying about Microsoft Word or something. I'm saying about what is thought.
Yeah, thought is something like Microsoft Word.
As you were saying, thought
what is the definition?
Is potentially measurable, right? I mean, you can measure brain function, and you can measure it when you're hungry or recoiling from some danger, or when you're thinking of third-order differential equations or something like that. And eventually, I can imagine that we can learn to differentiate these modes of thought.
The neural correlates of thought.
Quantitatively, you know, you have patterns in the brain, and one can obviously the pattern when you're recoiling from danger is not the same as when you're inventing general relativity or something. But in principle, we can learn to quantify those things, or at least so it is it potentially is measurable, right?
So I think what is not measurable is yes, you can measure the neural correlates of thought,
right?
But that is not an explanation for thought.
Yeah, right.
In the same way as
correlates, right? I see.
In the same way as you can say, when Newton figured out the law of gravity, he only talked about the correlation of gravitational force to the masses and the distances. He's not explaining gravity. He's saying this is the correlation of this principle to these measurable things. Similarly, you can say, when this person says he's thinking about his grandma, these are the circuits that light up. But just knowing the circuits is not the same thing as understanding, is explaining the feeling of grandma. That's not the same thing. And to get from one to the other, that takes a
right.
That's a real understanding.
It's also consciousness is not a yes/no thing. It's a gradual thing. I mean, when a fetus develops, it doesn't have any thought when it's a fertilized egg, but it gradually becomes conscious over time. And There's no yes, no, is it conscious or not, you know.
Right. Yes, it's a continuum, yes.
Yeah.
But I would say, yeah, like spider, like I think my system is closer to like spiders learning to make webs. How does a spider know how to make webs? It just happens that its parent spider had the same hardware that made it make webs, and therefore it made more spiders.
Mm.
I think it's something like that.
So Souvik, so my question is, do the bots think that they are something?
That is the question.
And I don't know.
I don't know.
But one can imagine if you have these other layers of this, if you enable inhibitory
Neurons,
patterns,
yeah.
then
I think it could start to make. Yeah, that's exactly the direction I was gonna go at.
yeah.
Is that this direct reflex arc probably doesn't know. It's not like something to be a reflex arc. It may be like something, and you know what I mean? It is not like it. I don't know. The question is it like something to be a cockroach? Maybe it is like something to be a cockroach. I'm saying it probably isn't like anything to be a reflex arc. But a reflex arc, layered on a reflex arc, layered on a reflex arc, layered on a reflex arc. Maybe it may be like something to be that. And I think it may be what it is like to be me. I think that's my thesis.
So are you going to write this up,
I
publish
probably
it?
should try to write it.
I think you should, yeah. Sad you're American.
Yeah. I could try that, yes.
So I got one more question. It might be a little contradictory. I see it as a contradiction in your approach. You're saying that you're quoting Feynman that what I can build, I can understand. But then you're saying that you can't even understand the neural networks that are going on right now.
Oh, yeah,
so
yeah.
eventually you're still going to have with the self that you have no idea what it is.
But he admitted that he has to learn about neural networks, how to understand
I am
to
good.
analyze
So
it.
yeah. So I agree. I do not understand what the actual connections in there are. So I can only say I understand the principle of which this is. I don't understand the details. I understand the broad brush.
But as these systems become more and more complex as they self-evolve, wouldn't it become impossible to understand what's in there? I mean, if it's
we will see.
Just as chaotic and...
I think there's structures emerging, and then I think we're smart enough. If we're smart enough, we can understand them. I don't know, but I think I'm offering. I think the best way to, if the structure of my brain happens to reproduce in a rat's cortical system, if I get some similar distributions, I can start by saying, okay, maybe I don't completely understand it, but it's probably what's happening out there. So I understand the general principle first. Now I go into now I really have an experimental or a theoretical handle on what's going on. I can probe into these models a little better instead of opening up 10 different rats. Yeah, but you're right. I mean, I don't claim understanding of the internals.
But actually, these survival issues are normally associated with biology, not with psychology or mentality, but with biology. Survival is, and this mechanism issue somehow simulated. I would say that it's biological model. It's not model of mentality of self-awareness.
What do you mean
which
mentality?
I do not.
What do you mean mentality of self-awareness?
Self-awareness, what else? To me, self-awareness is mental thing. It's about mind. But survival, it's not about mind. Survival, it's about life. Mind and life.
I'm saying that comes from.
And life are two different.
Why do you think they're different?
Entities.
I'm saying they're not.
This is arbitrary statement.
Yeah, so I think
mind is about thinking. It's about ideas. What you are suggesting for us, this is results of your mind. You are suggesting us our ideas. While biology starts, from cell, from amoeba or whatever, infusoria, very little. Nothing about ideas. We are not talking about ideas of this particular even rabbit, not about...
No, once they start evolving neurons, when they have nervous systems, they begin to have these complicated brains that I think have ideas. And they experience what it is to be these brains is to have the thoughts.
To me, you are mixing two very different things. Life and mentality, thoughts.
That is precisely what I'm trying to do. I am mixing that. I am saying these are actually one thing. Recognize the
okay, we will talk more about this,
yes.
but I'm just highlighting that to my that as far as I understand it.
I think because you're coming from a dualistic principle that there is the mind stuff, that Cartesian dualism.
No, first of all, I would like to separate them and see clearly that whenever I see say cells or some cell biochemistry or self-reproduction. It is about life.
Right.
Hunting for some food, it's about life.
Right.
But mind is, for instance, this is the result of mind. What you showed us, your ideas, your model, your way to convince us that this has some relation to reality. This is about mind.
Yeah.
Those are ideas,
But if someone
thoughts.
injected chemicals into my brain, I would not be able to think
This is
these
completely different level of beings. And so you are so easily mixing these two
things.
together.
No, I'm saying one comes from the other. In fact, if someone put chemicals in my
This
brain,
is-
I would not be able to think these things. These
So
are-
you are not showing that one comes from another. You are just arbitrarily mixing them. That's what I see. But we will talk more about this later.
Okay.
So I think we
All right.
already